These sequence of videos are going to show you how to do certain parts of the long test using the TI Nspire. It looks a bit different. This is the TI Nspire software I have for my iPad. It works in exactly the same way as the calculator works. So I don't want to do everything because I don't think everything needs to be done on the calculator, but 1C is a good one. So I've put a new graph page and I'm going to type in the function f1 of x, so it's going to be 1c, so that's x squared minus 8x plus 2. Enter. And you're going to see that at the moment I'm slightly too far out from this. Now, you go into menu. I don't think I can quite do it the same way. I can. Windows zoom, and we can. Yeah, okay. I can't do zoom out like you can. I'll just do zoom out, but I think I can do a pinch to zoom. So I'm going to zoom out like this. Keep on zooming out, and you can see the minimum point is down between -2 and 4, but down here. So go menu, analyze graph, minimum. Find the lower bound, anywhere left of the minimum, anywhere right of the minimum, and I get 4 minus 14. And that's how, so I know that my function, my range must be greater than minus 14, why it would be greater than minus 14. If I add a calculator page to the document, and I type in domain of that function, which I called f1 of x, so I need to open a set of brackets here. Your brackets are much easier to do than my one, so I'm going to go back here to do my brackets. Back there. Well, actually, I could probably do it in here, couldn't I? Where's my f gone? Nope, they're not allowed to have it there, so go back in here. f1 of, open more brackets, yours is so much easier than this, of x, and then I have to put comma x, which would be lovely if it was in that one, but it's in here, comma x, and I push return, and that tells me that my function can take all real values for x. I'm now going to do the next question, which was determine the parity of them. Now I'm going to do this once because I don't think it needs to be done again and again and again. So I'm going to add a new problem. I'm going to add a calculator, and I'm going to define my function. So I find f1 of x. I don't know how to define on this calculator actually. On yours, I've shown you many times how to do it. I'm going to guess. I'm going to do colon equals, but it might not do like. It definitely does with your calculator though. And I'm going to put in 2x cubed plus 5x. 2x cubed plus 5x. So this is 2c, but all works the same for all the others. Push enter. Okay, that's defined it. I now type in f1 of minus x. Where's my minus has gone? Go back in here for a minus. And you see that's minus 2x cubed minus 5x. Now, you should already see that's been the minus version of it, so it's odd, but you can go into, you could actually say factor and select it, and you'll see the minus comes, oh, okay, I didn't want to have the minus x, so forget about that. We can add a new graph, and we can see what f1 of x looks like. Just go and scroll up on your thing, and you can see that's clearly an odd function. Okay. Question 3, but what I want to do is I want to do 3 part B and 3 part C, but I can do this all in one go. So I'm going to add a new problem. I'm going to add a graph because I'm going to define. I can define this function in many different ways, but this is maybe the easiest. X squared plus 3x minus 5. Enter. There's my function. I'm going to add a new calculator page, and you're going to see this function, because it's in the same problem, it's not a new problem, it's already defined for me. That's what I just typed in. Now, if I say f2, remember, calculator prefers f's rather than, sorry, it's in capitals, I don't want that to be in capital. f2 of x. Okay, and we're going to define this function. Now, I know the question says g, but the calculator prefers f. So I'm going to define it like I did before, and I'm going to say this is f1, goes bold because it's a function that's been defined. And I'm going to type it in exactly as we see in the question. And I push enter, and that's it been defined. So now if I just type in f2 of x, I get the x squared minus x minus 4, which is what I did on the original video explanation. I go back to, I have to go back, I don't know how to go back. If I can just, if I go to the, I think, okay, I don't really want to do it like this, but you can go back between things much easier than I can. I'm going to put in the other one, graph entry edit. Again, use type tab. This is when yours is far more powerful than mine. Function and F2. Click enter. You get all the values of that. Okay, you can see them and sketch them. I'm just going to zoom out slightly. Menu. Back to the main page, which what you'll have: geometry, points and lines, point on, select your function, and then you do your point, select your function, do your point. Oops, missed the point. So let me see if I can do that again. Oh, it's okay. Your calculator automatically does this. Mine doesn't. Point on, select your function, put your pointer on the intersection. That's why it's point on. Select the point on. Select your function. This is where I'm getting everything from. Select your, and so on. Okay, that's not what I want to do. It's not that one there. I need to zoom in. So let's try again. Point on. Select your function. There you go. That's that one there. A few more. Point on. Select your function. There. Select your function. Point on. And you notice your points are either x is either 0, or in the last couple of cases y is equal to 0. So that was question 3. No 4, remember? So question 5. No, I'm not going to do that on the calculator. Well, okay, I'll do it on the calculator very, very quickly. Add new problem. I'm going to add a calculator page. I'm going to do part B. Okay, so I'm going to define the function f1. Remember, this is a new problem. That's why f1 hasn't been defined yet. f1 of x is defined as x cubed minus 5x squared plus 2x minus 1. Push enter. The derivative function is menu. I've got it here anyway, so I'm going to do it this. So I'm going to derive it, and that's the derivative of f1 of x. Push enter. So that's where before. The coordinates of the turning points. Okay, so I type in solve, open brackets, put that in. So I just selected it by going up, push enter, equals 0. Oops, 0, comma, x. I get two values. If I do Control Enter on the calculator, I'll get everything that I absolutely need, as a decimal form. If I go to add a graph in this particular problem and go into Enter, I've got myself 2 turning points. If I go to Analyze Graph, maximum, left of it, right of it, I get the point 0.214, comma minus 0.791, and also do it again. the minimum, left of it, right of it, you get 3.12 and minus 13.1. You want to determine the nature of the turning point. I wish I could remember how to go back in this document. I can't remember how to go back in this document. Okay, so I'm just going to add a calculator page into this this part here. Determine the nature of the turning point. You want to differentiate it twice. You want to do a second derivative on it. So I can go into menu, calculus. There is that's a bit too challenging. Your calculator is much easier. You can do the second derivative of it, but unfortunately for me, I don't have that. Oh, I have it. Oh, I do have it. Okay, I'll do that. D2 over D. I have it. Okay, you have got this one as well. Learned something new today. F1 of x, and you've got the second derivative, which is what I showed you before. So that's 5. 6. Add a new problem. I'll add a graph. I'll put the function in for x squared plus 5x minus 2. Push enter. Menu. Analyze graph. Minimum. Left of the function, right of the function. X has to be greater than than minus 0.625. And then question 7, we add a new page, add a new problem, add a calculator, determine the gradient of the function at x equals minus 3. So we have determine the function, as I've done many times with you already. So that's going to be 5x squared minus 4x plus 2. This time I'm going to do slightly differently. I'm going to define my second function to be the derivative of f1. Remember, it's differentiated with respect to x, that's why I put an x in there. So find f1 of x. Push enter, and that's done that. So when I've differentiated it, that's just basically f2. If I put f2, oh, I don't know why it was done like that. f2 of x, I get the derivative. And if I do f2, but I put in the number, minus 3. I get the value of minus 34, which is what I was looking for. Now, I showed you how to do question 8. I'm going to do another way of doing question 8 for you. You should be able to do it without the calculator for this. So we're going to do the following. We're going to define the function. You're getting probably fed up with me saying define the function. Whoops. I'm probably fed up with me making silly mistakes. There we go. The function was 3x minus 2. Nice, simple linear function that you should have been able to manipulate when you were in first year, certainly. So that's defined. And now I'm going to do a solve. Open brackets. f1. Now we're replacing the y's and the x's, so they're going in the opposite direction to what we normally have. Is equal to, what's my equals gone? Equals x, and then we comma y. So it's a bit different to how you normally see it. And you get the value we had before, and rather than be y equals x plus 2 over 3, we make it f minus 1. And yeah, that's how you do it using the calculator.